Hello, once again. Welcome back. We're now on chapter 15, and at this stage we have a good understanding of how garbage collection works. And in this chapter, we're going to learn about what we can do as programmers to tune the process. That is, we'll be able to make it work in the most efficient way for our particular applications. There are a number of different garbage collection algorithms that Java can use, and these are known as garbage collectors. The Java virtual machine decides which is the best based on your hardware, and we'll see how to find out which type of garbage collector your computer is using in just a moment. But you can change this and tell the virtual machine to use a different garbage collector if you like, using a runtime argument. Before we get to that, however, there's another runtime argument that you might find useful if you want to monitor how often garbage collection is taking place in your application. Now, of course, you can check this using the Visual VM application, as we saw in the last chapter, but if you just want a quicker way to monitor garbage collections, this might be a useful option. So the argument is -verbose :gc. This isn't one of those -xx : arguments, it's a bit simpler, and the verbose argument does have some other options which you can output. But as these aren't related to memory or garbage collection, I'm not going to be covering those in this course. You can, of course, go and read the Java docs if you're interested. So let's just see this one in action, and I'm going to create some simple code. We'll work in the same project that we've been using for the last chapters, because I'd like to be able to use the customer class that we have, but I think I'll create some new code that will run from scratch for the purposes of this chapter. So let's create a new runnable class, and I think we'll just call it main. I'll tick the box to create the public static void main. I hope you're following along with me. So in this class, what we would like to do, it's not going to be too exciting. I think I want to be creating and removing customer objects so that we can be creating objects that will need to be garbage collected, but I'd like to do this in quite a managed way. So what I think we'll do is have an array list to store some customers in. Let's create that first. And we'll just call it customers and instantiate it. And then we'll have a never-ending loop. And within the loop, we'll certainly do things like create a new customer and add it to the array list. And I think we'll just give every customer the same name, which can be Matt. I don't really care about that. Let's add that customer to the array list. And then what I'd also like to do is say, when the array list gets to 100 or more customers, we'll remove 10 of those customers from the array list. So this array list is going to be a limited size. It's only ever going to be 100 customers. But when we get to 100, it will actually drop down to 90. We'll add 10 more, it will drop down to 90. So we'll be constantly creating 10 customers that are no longer referenced, which will be available for garbage collection. So let's just do that bit. We'll say if the size of the array list is, I'll just put in greater than 100, I think, then we will say we want to remove 10 customers. I think the easiest way to do that is with another loop. So let's say for int I equals 0, I is less than 10, I plus plus. And for the loops running, we're just going to do customers.remove, and we'll remove the first item in the array list. So I think that should do what we want. Let me just make sure we've imported all the right objects. That's array list imported. This looks to be compiling, so that's good. So we'll run this application, but before I do that, I'd like to use that runtime argument. So we'll click on Run and Run Configurations, and in the Arguments tab, I've still got here the argument that is going to run this code with a 10 megabyte heap. I think that's absolutely fine for now. Let's add in the extra argument then. So we'll just put in a space, and it's -verbose :gc. Actually, I think I'll make my heap smaller, because that will then cause the garbage collector to work more hard to make sure there's enough space. We'll see some more output. So let's run that and have a look at what the output looks like. And we've immediately got some printing out to the console to tell us that some garbage collecting is taking place. I think I'll stop this now and I can explain to you what this code means, what the output means. So each line here will either say GC or full GC. If it says GC, that means it's a minor garbage collection or a garbage collection on the young generation. A full GC is a major garbage collection, a garbage collection on the old generation. In brackets, we get told the reason for the garbage collection. Allocation failure means there wasn't enough space in that part of the heap to create a new object, so it had to do a garbage collection to free up some space. The ergonomics means that the Java virtual machine is trying to change the structure of the heap to make this perform well. We'll actually understand a bit more about how that works a little later on in this chapter. We then get two numbers separated by arrows. That is the size of the heap before the garbage collector runs and the size of the heap after the garbage collector runs. In brackets, we have the total size of the heap and then the amount of time it took for the garbage collection process to run. Now, clearly, this is an extreme example because we're running some bad code in a very small heap, so we're getting huge amounts of garbage collections, but that at least is the output to verbose GC, which might be useful for you if you are trying to monitor garbage collection to see how it goes in a quick and easy way.